Okay, just to show you a few things. Um, this is a rotor that went in my big generator, and I replaced it with a rotor that has the same number of magnets, only they're twice as thick as these. So this is an extra rotor I had, and this is the way the big generator works. When a magnet is aligned with a coil, and because there's only 6 coils on each side, there's only every other magnet is aligned with a coil at the same time. But anytime a magnet is aligned with a coil, there's a magnet out on the stator. That's what these holes out here were for, was for magnets, for square magnets to align with magnets out on the stator. So if this magnet was aligned with a coil, this magnet on the stator would be, this magnet on the rotor would be aligned with a magnet on the stator. The same thing with this one. When it's aligned, the magnet here would be aligned, as you can see, all the way around. So this rotor actually went on my big machine. I am just going to cut it down, and it'll be a smaller rotor. It'll only be as big as this one is. This is just an old rotor, just to give you an idea of the size. I'm going to cut it down, and then this rotor will go on that machine that's over there on the bench. Now, this rotor is much bigger, and it also has 12 magnets on it. But if you look at the diameter of these, and then you look at the diameter of those, if you looked at how this sat on here, and you could actually see the magnets at the center of each one of these, if you put this on here, the magnets are farther out, and that's because that particular rotor fits on this machine. And the way it's set up is anytime a magnet on the rotor is aligned with a coil, the magnet on the rotor directly opposite it is lined up with an opposing magnet. That's what all these smaller holes with the plastic pipe in them are for, is for the opposing magnets. And they match up with, anytime there's a magnet aligned with this coil, there's a magnet on the rotor that's directly aligned with an opposing magnet here. The problem with this machine is only this coil and the one on the other side of the rotor are producing power at one time. So it's basically 5 phases. This phase, this phase, this phase, this phase, and this phase. While on this machine, all 6 coils on each side of the machine, so all 12 coils are positioned in front of a magnet all at the same time, which is also why it costs you more amps on your motor to turn this rotor than it does to turn this rotor, where only one magnet is aligned with a coil at a time. And so overall, this one's much easier to start, but when you get right down to it, the amp draw is actually just a little bit less, but the only reason it's less is because this one only has 10 coils in it, while that one over there has 12 coils in it. So the fact that this has less amp draw is not because of this alignment situation. It's because this has fewer coils. Overall, the amp draw per coil is the same when the motor is at speed and everything is running at full blast. So I don't like the 5-phase situation that you have right here, but it's great for demonstrating that everything can work the way I say it will. But you got to have a big machine with this kind of a setup in order to have the opposition magnets aligned at the same time that the generating magnets are aligned. So there's as much information as I can give you about that.